Okay, the talk now is an example of vagueness in Einstein's relativity, and there's quite a few examples we can give where things are not very clear, but this is an example which goes back quite some way to Herbert Dingle, and so we're going to get into this. Herbert Dingle is mentioned at Wikipedia at this place, so a quick look at that. Herbert Dingle was an English physicist and natural philosopher who served as president of the Royal Astronomical Society from 1951 to 1953. He is best known for his opposition to Albert Einstein's special theory of relativity and the protracted controversy that this provoked. So, going into a bit more detail, initially he was a supporter of Einstein's relativity, and then later changed his mind and decided that it was wrong. And I think the reason why he decided it was wrong because he found out that there was lots of different opinions as to what Einstein's relativity was. So I think he decided it was a vague theory. But if you go for the mainstream, those who still believe in Einstein's relativity, of course you get a different sort of take on it. So if we go back, next I will be referring to a lecture by McClawson called Reviewing the Riddle of Relativity, and McClawson is carrying on the work of Herbert Dingle. He's looked into the issues that Herbert Dingle looked at, and he's still carrying on opposition to Einstein's relativity. And I'm not going to show all of the lecture, I just want to refer to the bit which I want to show as an example of vagueness in Einstein's relativity. So there's actually more to McClawson's talk than what I'm going to deal with. I'm just picking up on a little bit of it. So let's now go to it. It's not there, so it's here. We can make it larger. Allow. Start this. This is the introduction to the talk from Greg Volk. So he's introducing the talk on McClawson.
Been active with the NPA many years ago, but hasn't actually come here to join us for a long time. It's a great thrill and pleasure to have you here. He just wrote a new book in the last year, which is in the back. I hope you pick up a copy. Dr. McCausland worked personally with Herbert Dingle, and if any of you don't know who Herbert Dingle is, you better find out, because he was one of the people who actually wrote books on relativity in as early as the 1930s. Am I right? I'm not sure. Real early, and he was the world's authority on Einsteinian relativity at an early date, and sometime later came to challenge Einstein's ideas, and wrote numerous papers on it, and got ostracized for his efforts. He did write a book called Science in the Crossroads in 1972, and it was about that time that you came in contact with him, I think. And so he kept up a correspondence and has been writing about issues of relativity for decades. So I'd like you to please welcome Dr. Ian McCausland.
So it's McClawson here, and it's as he said about, Greg has said about Herbert Dingle. Herbert Dingle had opposition to Einstein's relativity, and this opposition is still ongoing.
Thank you very much, Greg. It's a pleasure to be here. And as Greg indicated, this is essentially about my collaboration with Professor Herbert Dingle. This is Professor Dingle. He was a very eminent British scientist. I think you can judge his eminence by the fact that this picture comes from the archives of the British National Portrait Gallery in London. This is a book, Science at the Crossroads, and it was published in 1972, so I'm celebrating the 40th anniversary of that. and the 40th anniversary of essentially my collaboration with him. He was essentially the first critic of the orthodox result of the clock paradox.
So he's saying he's the first critic. Actually, criticism to Einstein's relativity goes back a lot longer than Dingle, but Dingle seems to be a more respectable critic than some of those before him. Some of them I pointed out were people like what's his name? Leonard, who turned out to be a Nazi. So we put at him. Philip Leonard here. So Philip Leonard, he was a Nobel Prize winner in physics, and he was criticising Einstein's relativity, but unfortunately he's got associated with the Nazis. So when we're going to people like Herbert Dingle, he's a bit more respectable critic of Einstein. So, get back into that again.
So the twin paradox, I'm sure you're all familiar with it. The twin paradox says that an astronaut going away into space and coming back years later would be younger than his twin brother who had stayed at home. He then he disagreed with that result. He said that they should age equally. Then later he came to the conclusion that both results arrived from the special theory, and that therefore the special theory contained a contradiction.
So that's Dingle. Initially, Professor Dingle was a believer in Einstein's relativity, and then eventually decided it was contradictory theory.
In my book, A Scientific Adventure, I described how he had written about this. And I also came to share his view that the special theory contained a contradiction, and my book is my book deals with that. I should perhaps explain this peculiar picture on the cover.
So there you go. So you can show a picture of his book. I'll do that.
This is a.
So it's supposed to be a picture from his book. So that's the problem. Many of us who've looked at Einstein's relativity think it's contradictory, and from my point of view, it's more like people who claim to believe in Einstein's relativity, they make different claims. You ask one relativity believer, who say such thing, another would say something different, and a third would say something else, and a fourth would say something else. So you've got all these people saying different things, and if you even go to textbooks on relativity, you'll find the textbooks, if you go back long enough and study them, you'll find that they say different things as well. And I thought, well, initially I thought to myself, well, some of these people, they don't really understand Einstein's relativity, and so I went back and I started reading Einstein himself to see what he says about relativity. And the problem with Einstein is that he keeps changing his mind. You say one thing one moment, and then a few years later you say something else. So all these people who have got different opinions as to what Einstein's relativity is, well, it can be traced back to Einstein, because Einstein was saying different things. Throughout his life he was saying different things. So you've got something that's very vague from the very beginning. It's not very clear what's really supposed to mean. So now we're going to go into the example of that vagueness. If we can clip on to position 5, we'll find it, 5. You're going to pick up now on an issue of Einstein's relativity being vague.
I think his colleague will laugh at him. I cannot exactly show that there's a logical contradiction on page 6, but Here's something that shows somewhat of a problem in the theory. This is one paragraph taken from this translation, and I split it into two parts because that's the way I did in some of the papers that I wrote. And the underlined part on the left-hand side is essentially the statement of the clock paradox, the orthodox result. If we have two clocks, one of them goes around in a circle relative to the other, then it is the one that moved is slow relative to the one that stayed behind. I think almost every relativist would defend this with the utmost tenacity. But when you look at the right-hand statement, a balanced clock at the equator must go more slowly than a precisely similar clock at one of the poles under otherwise identical conditions. They're not nearly so sure of the ground. Excuse me. The footnote says not a pendulum clock, but this is physically a system to which the Earth belongs. That shows that he's talking about a real result and not just a matter of observation. Now, Dingle asked the question about that particular result. He said, applied to this example, what entitled Einstein to conclude from his theory that the equatorial and not the polar clock work more slowly? Here's one answer. There are three answers from Dingle.
So what we're going to have, Dingle's asked a question and there's going to be three different answers to Dingle's question from three different people who believe in Einstein's relativity. So
real result and not just a matter of...
It suddenly clicked. What did I do just then? Finish touching. If I can bring it back again. So that's Dingle's question. Dingle asks this question and he's going to get three different answers from three different people who believe in Einstein's relativity. So this demonstrates that Einstein's relativity is vague because you're not going to get one answer to a straightforward simple question. You're going to get several different ones. And that is from people who believe in relativity. People who believe in relativity are not going to believe the same thing.
Not the polar clock work more slowly. Here's one answer. There are three answers from Dingle, reviews of Dingle's book. He says the relative motion is non-uniform, therefore he says Einstein was wrong. Although he doesn't admit defeat. He says the prediction is not invalid because he was anticipating his later theory. Now, I hold the view that any answer to Dingle's question that's a valid answer must have the property that it would have been a valid answer if the question had been asked right after the paper was published. So if you imagine somebody being asked, or if you imagine Einstein being asked right after the paper was published, how do you justify this statement? Supposing he'd said, well, I'm not quite sure, but I'm working on a new theory, and so come back and ask me the question in 10 years' time, and I'll give you your answer. This is Whitrow's answer.
So I want to go into that in a bit more detail. I've got it written up here. So what basically Einstein did is a calculation on some clocks, one clock going around another clock. And he got three different answers to that from his believers. So this is the first one. This person says Einstein was wrong in saying that his prediction followed from the special theory of relativity which deals only with the effects of uniform motion. So if this person is believing that special theory of relativity only deals with uniform motion. Now, I've talked to various different people who believe in Einstein's relativity, and not everybody believes that. Some people believe special relativity applies to non-uniform motion. So it's only what this person believes. This person believes special relativity applies only to uniform motion, but that's his opinion on that particular issue. But going with that, saying that's what he believes, carrying on from that, this is not to say that the prediction was invalid. So he's referring to a calculation that Einstein did, and he's saying that the calculation was not invalid. For Einstein was intuitively anticipating his later general theory of relativity. So you've got this ambiguity now. You've got the cross between special relativity and general relativity, and this person is stating his beliefs. This person is stating his beliefs on the cross between special relativity and general relativity. So I think what he's saying can be summarised as Einstein was wrong to say it's special relativity, calculation is valid, but it's anticipating general relativity. So that's his point of view. Basically, the calculation is involving general relativity and not special relativity. That's basically what his view is on it. So I think that's basically what he's trying to say, that person. So next we go on to see what the other people have to say.
I don't want to spend time in dealing with it because there's a lot that could be said about it.
This is Whitrow's answer to it.
But the main point I want to make is that he is obviously supporting Einstein's view that the clock at the equator is working slower than the other one. Here is Maddox's answer.
So he was a bit too quick on that one, on Whitrow's answer, so we go back to it and have a look at Whitrow's answer. So, according to Whitrow, for a support of relativity, the essential difference between the two clocks is that relative to the centre of the Earth, which for the purpose concerned can be regarded as the origin of an inertial frame, the clock at the equator describes a circle and so cannot be associated with an inertial frame for a period of time during which the curvature of the Earth's orbit can be neglected. So he's dealing with the issue of what is the inertial frames involved for these clocks, and it's all sounding very confusing to me. And what I'm picking up from him is, in general relativity, you would have to consider the curvature of things like space-time, which would be general relativity, and he's saying ignore that. So or even if you're treating it from the point of view of Newtonian physics, you've got the curvature of the Earth's orbit, and he's saying neglect these things. So I think he's talking about is he's treating the answer as an approximation. You're neglecting these Spall effects, what he thinks are Spall effects. So I think it could be summarised as his point of view. His calculation was an approximation. So that's what I think he's saying for his point of view on what Einstein gave. So now we're going to go on to Maddox. Maddox, this is the third answer.
It says that Einstein was confused, or was confusing, and he says one clock is in a reference frame, the other clock's in a different reference frame, whereas Whitrow's answer, the previous one said that one is in a reference frame. And,
I think I should go back to a bit here, Maddox's answer. If I go into details about Maddox's answer. So this is the third one. So Maddox's point of view. It seems now to be accepted that Einstein's original argument was uncharacteristically loose. That means it was vague. The point of the illustration is that a clock at the pole of rotation may be taken to be in an inertial frame, which is nearly but not quite properly defined by the direction of the Earth's motion around the Sun. The clock at the equator is in another i.e. frame. Einstein's lack of clarity concerns the inertial frame of the observer of the two clocks. So what he seems to be saying, as what McClawson points out, is Einstein is confused and confusing. So that's his point of view. Einstein is not very clear in what he's saying. So that seems to be Maddox's point of view. So we'll go through it. The first point of view seems to be Einstein is wrong to say it's special relativity, and we really should be talking about general relativity. And the second point of view is calculation was an approximation. Third point of view, Einstein is confused and confusing. So that's what we have. Einstein gives an answer based upon his theories of relativity, and he gives makes his people who believe in him give three different answers. So this is an example of how badly Einstein's relativity has been presented. It splits even the believers in Einstein's relativity as to what is meant by it. So I'm going to say something that has been so badly presented so that it's not clear what is meant should be discarded. Einstein had time to clarify numerous issues but never did clarify what he meant. So that's my point of view. Einstein's relativity is just too vague. Einstein started talking about things, started changing his mind, and it's just too vague. What's he talking about? Physics should never be built on something as vague as what Einstein's given us. And it didn't like that, did it? So we go from this one.
Clock at the equator is working slower than the other one. Here is Maddox's answer, which says that Einstein was confused, or was confusing, and he says one clock is in a reference frame, the other clock's in a different reference frame, whereas Whitrow's answer, the previous one, said that one is in a reference frame or associated with a reference frame and the other cannot. So there's all these three different answers. I made up an argument from the statement about the polar and equatorial clocks.
So he's going on to now talk about what his conclusions are from it. But basically, there's a lot more to the talk, but basically I'm only highlighting the fact that there's the three people who believe in Einstein's relativity, and they're coming to different conclusions. They're thinking different things. They're not agreeing. They are agreeing that they believe in Einstein's relativity, but they're not agreeing what it means. If we go through it again, first point of view, it's Einstein was wrong to say it's special relativity, and it's really general relativity. Second point of view, calculation was an approximation, and the third point of view, Einstein is confused and confusing. So if you probably asked another person, you could come up with a fourth possibility. It's just how bad Einstein is. And so it leads us to, no one knows what Einstein's general relativity is. Nobody knows what his relativity is in general. You don't know. It's just Einstein saying a lot of things and changing his mind. It's not something you should build science on. It's just vague. So I've got this. If we go to this one, I point out that it remains unanswered as to what Einstein's relativity is. And through this one, I explain, I go through a paper. We have a quick look at it. The talk is, it remains unanswered as to what Einstein's relativity is. The mainstream does not agree what Einstein's relativity is. The paper I'm going to refer to is called General Covariance and the Foundations of General Relativity, 8 Decades of Dispute by John D. Norton. So John D. Norton is supposed to be somebody well up as an Einstein scholar, and what you get is people talking about Einstein's relativity and they're not agreeing. And they've been going on for ages. It's been going on from the very beginning. It's sort of, when the paper was written, it was 8 decades of dispute, and it's still carried on. We're now, I think, in 100 years of Einstein's general relativity, and we now have 100 years of people not knowing what general relativity is. So this highlights the problem. We are completely... It's an example of the vagueness in general relativity. You try to ask a person who believes in general relativity, what is Einstein's general relativity or special relativity? You try to get them to explain what Einstein's relativity is, and they just come up with lots of vagueness. Then they won't give a precise answer. It's just vague. And Herbert Dingle tried to point this out, and he's just got ignored. If we go to him, Herbert Dingle he lived 1890 to 1978, and he was trying to point out this problem with Einstein's special relativity, which actually goes on to general relativity as well. It's just completely vague is what it means. So there you go. And he wrote about it in his book Science at the Crossroads, and it's been taken up by McClawson. This is the book here, Dingle, Science at the Crossroads. It's still been taken up. We who are saying that Einstein is wrong, we have still carried on. And none of these questions have been properly addressed by the mainstream as to precisely what is Einstein's relativity. It's just a vague mess. Sometimes they point out Einstein is a marvellous guy, he was prepared to change his mind, but when you read him, all you've got is changes of mind, and it's just not clear why did he change his mind. And that's led to a great deal of confusion. No one knows what Einstein's general relativity is, and they don't know what his special relativity is by the example given. They just don't know what it is. It's just completely vague. Thank you.